just love to survive. Now when I look in your heart, it's gonna be okay. Everyone needs a bad day. Remember you told me you're not alone. Just pick up the phone.
Hi everyone, my name is Kuteng Hao. I'm from SPH. I'm the first member of Group A. So the scope that we selected is the parking slots next to Masjid in YMK Campus Jeli. So the ChatGPT generated a questions for me, which is the number of cars parked in the university parking lot at any given time given by the functions pt equals to 5t power 2 plus 10t plus 20, where t is the time in hours since the parking slot open. Find the rate at which the number of cars in the parking lot is changing after 2 hours. To solve these questions, we have to find the rates of change of the numbers of cars. We need to take the derivative of the functions pt with respect to time, t. Differentiating pt with respect to t, we will get these solutions. After that, substituting t equals to 2 into the derivative, we find this. Therefore, the rate at which the numbers of cars in the parking slot is changing after 2 hours is 30 cars per hour. That's all for me.
Hi, my name is Shukrina Aisha binti Fakhur Razi from SPH. I'm the second member of Group A. The event that we selected is the parking slot next to the masjid in MKJL campus. So, ChatGPT generated a question for me. The question is, the area of the university parking lot is decreasing at a constant rate of 2 square meters per minute. The length of the parking lot is initially 50 meters and decreasing at a rate of 1 meter per minute. Find the rate at which the width of the parking lot is changing when the length is 40 meters. To solve this question, we have to denote that the length of the parking lot as L and the width as W. We are given that dL over dt equals to negative 1 meter per minute and dA over dt equals to negative 2 meters squared per minute, where A equals to L times W is the area of the parking lot. To find the rate at which the width is changing, dW over dt, when the length is 40 meters, we can use the product rule. Differentiating the area function with respect to time, we have plugging in the given values, we have negative 2 equals to negative 1 times with W plus 40 times with dW over dt. Simplifying the equation, we get, by substituting the length L equals to 40 into the equation, we can find, therefore, the rate at which the width of the parking lot is changing when the length is 40 meters is 0.95 meters per minute. That's all from me. Thank you.
My name is Nur Izzati Shakina binti Muhammad Zanzuri. I'm the third member of Group A. So, ChatGPT generated a question for me. That the question is the speed at which a car enters the university parking lot is given by the function Vt equal to t minus 5, where t is the time in minutes since the car entered. The question is determined when the car is accelerating or decelerating. To solve this question, we have to determine whether the car is accelerating or decelerating. We need to examine the sign of the derivative of the velocity function Vt. Taking the derivatives with respect to time, we have, since the derivative Vt is constant and positive, the car is accelerating throughout its entire journey in the parking lot. That's all from me. Thank you for listening to my explanation.
My name is Muhammad Arifin bin A. Aziz from SBH. I'm the fourth member of Group A. The event that we selected are parking slot next to Masjid in UMK Jeli campus. So, ChatGPT generated a question. The question is, a car is travelling through the university parking lot in straight line and its position at time t is given by, where x is measured in meters and t is in seconds. Find the velocity and acceleration of the car at any given time. To solve this question, we have to find the velocity of the car at any given time t. We take the derivative of the position function with respect of time. The velocity function gives us the car's velocity at any given time. To find the acceleration of the car, we take the derivative of the velocity function with respect to time. This acceleration function is constant and equal to 6. Therefore, the car's velocity is given and its acceleration is constant at any given time. Thanks for listening to my explanation.